Hey everyone, my name is Ruben. This is my presentation on exploring the anterior mid-cingulate cortex. This is for my psychobiology class, course number 2070, section 501. The time of this presentation and research done is here in the year 2024. And before we can start talking about the anterior mid-cingulate cortex, we have to take a deductive standpoint and start more broadly. And we'll start with the cingulate cortex. So what exactly is the cingulate cortex? If we see here in image 1, what I'm highlighting here is the cingulate cortex. But what is the cingulate cortex in this sagittal view? The cingulate cortex is a fold of cortical tissue on the inner surface of the cerebral hemispheres. So in this view, this is from the right, and on the right of image 1 is the anterior, so this is the front. So your forehead would be here, and the posterior to the left, which would be the back. And the cingulate cortex, composing of all three of these regions, actually sits located just above the corpus callosum, which connects our left and right hemispheres. And if you look at image 2, also another sagittal view, but the anterior being to the left, posterior being to the right. This again is the cingulate cortex and corpus callosum right beneath it. Traditionally, the cingulate cortex was subdivided into several subdivisions, including the anterior cingulate cortex and posterior cingulate cortex. The anterior mid-cingulate cortex is located about a third of the way behind your forehead. So right here, as you can see, I'm circling, and it's located on each hemisphere. So we actually have two anterior mid-cingulate cortices, one on both sides of the brain. But why should we care? Why should we care about this small region in the brain? And before we get there, we actually have to continue talking about the cingulate cortex just a little bit, defining the anterior cingulate cortex and the posterior cingulate cortex, as well as some of the history behind discovering the anterior mid-cingulate cortex or mid-cingulate cortex, depending on which studies you're looking into. So to start out, we're going to look at the image to the right here. It's a model according to Vogt et al. In 2004. It's a little old, so it's about 2 decades, but it's still valid for the most part, and we'll talk a little bit more about that. So as you can see here, this is the anterior cingulate cortex, the anterior mid-cingulate cortex, and the posterior cingulate cortex, as well as the retrosplenial cortex, which is a part of the posterior cingulate cortex. The aCC is actually deals with cognitive control of emotions, anticipation of reward, and autonomic control. We know from recent data the aCC is interconnected with prefrontal, parietal, and subcortical regions involved with valuation and action selection. So that's this part here. This is the part closest to your forehead. The posterior cingulate cortex, known as the key hub of the default mode network underlying audio biographical memory retrieval. It is thought that the posterior cingulate cortex and retrosplenial cortex respectively support the integration gradient of executive, mnemonic, and spatial processing systems. So this image is a little old, and it is important to realize with recent data that the posterior cingulate cortex is actually split into several regions as well, two being the ventral posterior cingulate cortex and dorsal posterior cingulate cortex, just as a frame of reference to remember. But the mid-cingulate cortex, with recent decades of studies and research, is actually been decided that is not a division of the anterior cingulate cortex, because it plays different roles and is a different region of the cingulate cortex altogether, which we will continue on about, since that is the main point of this presentation. Just one more thing with the retrosplenial cortex. As you can see here, it's actually connected at Brodmann areas 29 and 30, and there have been neuropsychological studies in humans that show that it's hard to really conduct for the reason of not being able to really isolate this area. But there have been studies in rodents and in patients with damaged retrosplenial areas that have shown evidence which supports that this area contributes to navigation and viewpoint frames of reference, which is important. So just a real quick, before we get into the bread and butter of this presentation, I just want to show This is Andrew Huberman. He actually introduced me to this brain region, and he's a great resource for science-based information regarding mental and physical health. He's actually a professor of neurobiology at Stanford School of Medicine and the host of Andrew Huberman Lab podcast. This is where I was introduced to this brain region. He didn't introduce it to me formally, but through his podcast and his lectures and his website, I value it quite a bit, and I highly encourage anyone who finds this presentation interesting to find his channel and specifically watch his episode on how to increase your willpower and tenacity. So going forward, now we get to the bread and butter. What is my favorite brain part? Well, if you haven't guessed already, it's actually the anterior mid-cingulate cortex. We now have functional magnetic resonance imaging in humans that suggests that aMCC is an important network hub that serves as a cost-benefit computation function necessary for tenacity. And you might be asking yourself, you might have heard that, but what is tenacity? Well, tenacity is really, plain and simply put, it's determination, it's grit, it's persistence, to achieve a goal even in the face of seemingly insurmountable odds. Due to the anterior mid-cingulate cortex's anatomical location and its hub centrality, neuroimaging studies show that the aMCC belongs to at least 5 somewhat overlapping brain networks, which is pretty impressive, and it's something we will circle back to in the next slide. Conducted experiments including diverse tasks suggest that the region is partly responsible for gradient integration of information about pain and negative effect in guiding behavior. Something to keep in mind. Some theories and models are still currently being debated and investigated by neuroscientists and anatomists as well. So we're going to continue. We're going to talk about never giving up. And we're going to talk about willpower, passion, grit, willpower, persistence, and tenacity, all kind of synonyms of each other, have all been strongly associated with academic achievement. So that's good to know. Research on tenacity suggests it is a strong predictor of health, aging, and academics. With the anterior mid-cingulate cortex's hub centrality, it supports previous hypotheses that state its importance in mobilizing physiological and cognitive resources that are domain specific to meet task needs. So the previous slide, how it overlaps with 5 different brain regions, this shows that its importance with mobilizing physiological and cognitive resources. So it can send these to these different brain regions when, where, and when and where they're needed. The aMCC's connectivity to the autonomic nervous system in part plays a role in our sympathetic system of fight or flight or freeze, which is why there's an image to the left of a frog who's almost being eaten, but his fight or flight, he's fighting and he's passionate, and he might break free. Who knows? Engagement in behaviors we seldomly don't want to behave in, as well as not engaging in behaviors we do want to behave in, has shown to increase the actual structure of the anterior mid-cingulate cortex to improve neuroplasticity. Very interesting stuff. Not only can we engage our anterior mid-cingulate cortex and access more tenacity and willpower, we can functionally exercise our aMCC so that by doing more difficult tasks, it allows us to do more challenging tasks that are unrelated. So the same, going back to the brain regions, I mean, if you're doing something uncomfortable in one part of your life, and this can, have a not a trickle down effect, but more of it can bleed over into other areas of your life, and it's really important here. So now that we know that, how can we strategically use this research to achieve goals? Now that we know that the anterior mid-cingulate cortex plays a huge role in tenacity and our willpower, I mean, it's the research suggests it's highly correlated. So actively doing difficult cognitive, emotional, physical, subjective, or objective challenges can increase tenacity and actually build the structure of your anterior mid-cingulate cortex. Rewarding yourself after difficult challenges can positively reinforce your behavior, leading to overcoming challenges in other areas of your life. A good way that I like to practice or exercise this part of my brain region is to take time and think about any discrepancies between cognitions or thoughts, and also just sit and do a bird's eye view of the discomfort that arises from these inconsistent thoughts to challenge myself with discomfort that may arise. Remember to not over reward after completion of challenges. You don't want to over reward. But yeah, I appreciate you watching my presentation. If there's any questions, please leave a comment below. If something I didn't say did not correlate with you, I also have attached the references for you to do your own research, and I appreciate it. And thank you for watching.